Numbers which involve square root, like these numbers here, are said to be irrational numbers because they cannot be written as a fraction of a over b, because the definition of a rational number is any number that can be written by a divided by b, where a and b are integers and b not equal to 0. These are known as surds. Okay, and what this chapter is about simplifying surds. Now, surds also can be things like cube root, but we're only going to deal with square root in this case. So it says, simplify the following, giving your answer in the simplest form. The square root of 24, the square root of 75, 5 root 3 plus 4 root 6 minus 2 times 7 root 3 minus 2 root 6, and then 3 brackets root x minus root y minus 2 brackets root x plus root y. Okay, let's deal with each of these cases now. So if we want to simplify this, okay, is what you've got to look at this number, and you've got to try to find the highest square number which divides exactly into it. Okay, so the highest square number that divides into 24 is 4. So we write 4 times 6. We haven't changed the meaning because 4 times 6 is 24. Now, for surds, the square root of a times b, which is what we got here, can be separated up into the square root of a times the square root of b. If you're not convinced of that, try a few values on your calculator, and you'll see that that is true. Right, so we separate this as the square root of 4 times the square root of 6. Now, the square root of 4 happens to be 2, so the answer to this is 2 root 6. Second one, square root of 75. Square root of 75 can be written as 25, the highest square number that goes into it, times 3. So separating up using this idea here, that becomes the square root of 25 times the square root of 3, which is, square root of 25 is 5 root 3. Right, 5 brackets root 3 plus 4 root 6 minus 2 brackets 7 root 3 minus 2 root 6. Now you're advised to proceed very carefully, doing plenty of stages of working out to avoid making mistakes. So expand the brackets. So 5 times root 3, like normal algebra, becomes 5 root 3. And then 5 times 4 root 6. 5 times 4 is 20 root 6. Minus 2 times 7 root 3 becomes minus 14 root 3. And then be careful here because we've got a minus times a minus, and that becomes a plus. So 2 times 2, that becomes 4 root 6. Now you collect together like a term. So we've got subterms which are root 3, so we'll underline those in orange. So 5 root 3 minus 14 root 3 gives minus 9 root 3. And then these two terms here are the same, which is 20 root 6 plus 4 root 6, which gives me 24 root 6. Maybe better to write it as 24 root 6 minus 9 root 3, because we don't like to have minus signs at the front of an expression. Now, there is a common factor here of 3, so that becomes 3 brackets 8 root 6 minus 3 root 3. Or, if you're really clever, you could say that it's 3 root 3 brackets 8 root 2 minus 3. Now, the reason you can say that is that root 6 happens to be root 2 times root 3, and therefore you'd have root 2 root 3 there, and you have a common factor of root 3 as well, so that could come out as well, and you're left with that one. This was slightly better, perhaps, than this one. The last example, so we've got 3 brackets root x minus root y minus 2 brackets root x plus root y. So that becomes, multiplying out the brackets, or expanding the brackets, becomes 3 root x minus 3 root y minus 2 root x. And a minus times a minus is a minus, so we get minus 2 root y. Identifying like terms, So these have root xing, so we've got 3 lots minus 2 lots, that gives me 1 lot. We don't bother to write the 1 in. And then you got minus 3y minus 2y, that's going to give you minus 5y. Okay, so this has been an introductory video about what a surd is and how to simplify basic surds. I hope you've understood, and I thank you very much for watching.